So this unit is about probability, and what we're looking at is our textbook. And I'm just going to scroll down to this one here. So it says casinos are a big business according to the American Gaming Association, $43 billion in revenue and so on. And then this is my note here. The study of probability originated in the 1600s with gambling. This highlight is my warning though. I know that the odds are against me, hence I never gamble. And so what you get from me is the advice: don't gamble. I know the mathematics of it, I know statistics of it. I'm not gonna win. By the way, when I say here in the 1600s, I just Googled that, and there it is. Pierre de Fermat and Blaise Pascal, they were very famous mathematicians in the 17th century. Pascal also in physics, for example, the metric unit for for pressure is measured in Pascal. And Fermat actually is kind of famous for Fermat's last problem, I believe it's called, which was solved 300 years after. Anyway, going back to probability. So the first section here is multiplication rule for counting. And yep, you can count these beach balls here, or you can arrange them like this. And here they have an example with cupcakes. So 3 choices for the cake itself, and then 4 choices for the frosting, and which means you come up with 12 possibilities. And if I wanted to compute that, I go to a calculator, and there will be my calculator here on Google. And this actually, oh, by the way I actually get to the calculator usually is by typing in 3 times 4, just to get there relatively quickly. There it is, 12, right? All right. I'll be using the calculator a little bit here, but then I'm also going to use this one here that's on my desktop simply because it's a little easier to squeeze in. All right, I'm going to go through here. So this is about cards here. You have 4 suits and 13 different cards in each suit, which means you have a total of 52. That's the typical stack of cards in at least the United States. By the way, in Germany it's 32 because it's 4 times 8. They leave out. Which ones do we leave out? 2, 3, 4, 5, and 6 is what we leave out. All right. Anyway, this one here, Joe's Pizza Shack offers pizza, 4 different types and 15. So 4 times 15 is obviously 60. There we go, right? And the other one down here, Pizza Shack again, 4 different types of crust, 15 toppings, 3 sauces, 2 cheese blends, so it's 4 times 15 times 3 times 2, there we go, and you come up with 360 different ways of doing that. Boy, whenever I go to Subway, it's like there's so many possibilities. You could have a sandwich. Let's see, that scrolled a little bit too fast here. Seriously, I think it goes from one page to the next. That's what it's doing. So this one is about license plates here, and this applies to Alaska. 3 letters followed by 3 digits. So how many possibilities are there? Well, it's going to be there 26 times 26 times 26, and then for the digits, it's 10 times 10 times 10, because of here the alphabet and here the number of digits you have. So this is the way to compute it. 26 times 26 times 26, and wait a moment, times 10. This is just too hard to type. There it is, by the way. There's the solution, 15,576,000 possibilities. Well, sometimes there's a shortcut. So instead of typing what I just did, I do 26 to the 3rd power, there we go, times 10 to the 3rd power, and of course I get the same result, 17,576,000, because 26 to the 3rd is 26 times 26 times 26. All right. So I'm going to say, yeah, this just scrolls a little bit too fast here to the next one. So here, ID cards, then chain of chicken restaurants. Oh, here I should point out, when you multiply these here, do not multiply 3 by 5 or something. No, what it says is your choice of 3 or 5 chicken strips. This is 2 choices, okay, that you have. And then there are 7 side dishes. So therefore, the outcome is simply 2 times 7, which is 14. Okay, this one here, as you flip coins, you have and you do it 10 times. So you flip a coin the first time, you get heads or tails, so 2 possibilities. Flip them a second time, heads or tails, 2 possibilities. So 2 times 2, because you could have heads, 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 tails, tails, heads, or tails, tails. So 4 possibilities, and then so on. So you keep multiplying 2 with itself. And so here, 2 times 2 times 2. No, I'm going to be too lazy to do that. It's 2 times itself 10 times, so 2 to the 10th power. There we go. 1024 times and possibilities, and if I do that on the Google calculator, it would be 2 to the 10th power, same number, 1024 possibilities. All right, t-shirt company, 5 times 8 times 4 times 5. Then this one here, going to class, the way the curriculum could look like, and let's see what else do I have here. Whoa, again, this scrolls sometimes too fast to the next page. It's kind of a bummer. Multiple choice question. 5 questions, 4 possible answers. So if you randomly take this quiz, then you have 5 times 4, 20. I'm sorry, I take that back. Almost said the wrong thing here. For each question, when you take it randomly, you have, which is what it says, how many different ways are there to respond to this quiz. So on the first question, you have 4 possible answers. On the next question, you have 4 possible answers. On the next question, you have 4 possible answers. 5 times, which means you multiply actually 4 times 4 times 4 times 4 times 4. 4 times itself 5 times. So 4 to the 5th power, which coincidentally also is 1024 times. That's, again, it's just coincidence with the last problem. In the United States, radio stations and so on, so first 4 letters. Here what you would do is actually the first is either K or W, so you only have 2 choices. So this is what you would do, 2 times, and then 26 choices for the next 3 letters, so 26 to the 3rd power. So you would get this one here, 35,000 possibilities. Sometimes I'm just going to abbreviate the number, because 35,000 is enough, or the one I had earlier was at 17 million or something. Let's see. Oh, and then one last one here. Board game. Mastermind has 2 players. 2 players here actually don't matter. One of them is designated code maker. 4 colors, 4 colored packs, which may contain repeats. The other player whose code player tries to guess the code. There are 6 colors that the code maker can use to make the code. How many possible codes can be made? And this would be here the game. I'll show you. So let's see. I actually have to pull it up. There it is. So here, in this case, we have 8. Okay, so the problem is at 6. And it allows duplicates. So let's ignore a couple of these here. We just make it 6 for now. So on the first one that I put in here, I would have 6 choices. So I could do this. On the next one, I have, again, 6 choices. On the next one, again, I have 6 choices. And there could be duplicates. That's what it says there. And the next one, I also have 6 choices. So it's going to be 6 times 6 times 6 times 6, which is going to be 6 to the 4th power. I mean, I can do this. Here we go. There it is, 1,296, or I can do 6 to the 4th power. There we go, 1,296. All right, that's the first section here. And then you will see the project, which actually will be covered in this one. That is playing the Mastermind game. So the project is to play one successful Mastermind game and hand in a screenshot. Respectively, just try to play the Mastermind even if you don't succeed to a solution and still hand in a screenshot. All right. Notice that this particular Mastermind game still has 4 pegs, but it has 8 colors to choose from. In a moment, I'm going to say allow no duplicates. For the time being, let's assume you may have duplicates, so you're going to have 8 possibilities here. Then you have the same 8-1 over here, the same 8-1 over here, the same 8-1 over here. So you could have potentially 4 green ones here. Okay. So, and any combination would be possible with the color. So it's 8 times 8 times 8 times 8, which is 8 to the 4th power, or 4,096 if I'm not mistaken. So 8 to the 4th power, there we go, 4,096 possibilities. Now, what I'm going to say is actually don't allow duplicates. So that means you can pick each color only once. So if I start out with red, then the next one must be another color here, must be another color, and so on. So that would mean I have 8 choices, 7, 6, and 5 choices. So that would mean 8 times 7 times 6 times 5, which will be fewer choices. Here we go. There you go, 1,680. In the next section, we will learn that has to do with factorial and what is called permutation. So let me show you that. And therefore, for this one, actually, the Google calculator is kind of faster than the other calculator I've been using. So 8 factorial here, which basically means 1 times 2 times 3 times 4 times 5 times 6 times 7 times 8. Pretty big number. It's like 40,000. And there are 8 different colors, each one only once. And then I divide that by the number of pegs that are actually there, so you can distribute them around only around 4. So 1 times 2 times 3 times 4. And notice I get the same answer, 1,680. But that'll be the next section. So again, I don't want you to use duplicates because I think it's going to make it a little bit easier because there are fewer possibilities, 1,680 versus 4,096. So let's give it a try. I'm just going to do this here. I'm going to take the first one here, red, at least I'm trying. There we go. And then green, I guess I click on this one here. There we go, there we go. And I have no idea what it is. So there, okay. This one here now tells me a little bit. The little red one here means that one of them is correct and in the correct place. I just don't know which. And the little white one here means that another one here is correct, just not in the correct place. So here's what I'm going to do. Again, I have no idea which one it is, so I'm going to put the red one here. I'm going to use the green one as well. I'm going to put it one over. There we go. But it could be the blue and the yellow one. I have to kind of guess here at this point. And I'm going to take the next color. There we go. I'm going to take the next color. There we go. And check again. And ooh, that's actually kind of worse. So I want to say that either the red or the green one is correct at this point. Again, I'm just going to guess here. So out of these 4, only one of them is correct. Then let's say if I choose the red one, then the green one cannot be in here, so it must be blue or yellow. So I'm going to try blue. And then of the 2 new ones right here, they're not there because I only get this one little red thingy here saying that only one of these is correct, and I already chose the red one here. And then the blue one from the first one because of this little red one. And I'm still guessing though. Okay, now I'm going to choose these 2 here. Let's see how badly I'm off. Oh, worse. All right. So this one here says 2 of them are here, but they're in the wrong place. So here's what I'm going to do. I'm going to say the green one actually was correct earlier on, and the red one is not. And I'm going to put it actually over here. And then I want to say the yellow one is actually correct, and I'm going to put it over here. Neither one of them is in the 3rd row, which means black and white. I'm pretty sure that there's a black and that there's a white, but they're not in the correct spot yet, so I'm going to put that over there. I'm going to put that over there. There we go. And let's see, check. Okay, this will take a little thinking on my part. Wow. Okay, I actually paused for half a minute to look at this and figure this out. So I want to say from the 1st row, I think I'm wrong about the red and the green. So I want to go with the blue and the yellow. So I'm going to take the blue in the correct place here. I'm going to take the yellow, being here in the wrong place. I'm going to put it way over here. And then from the 2nd row, actually it's either the brown or the red that are in the correct spot. So I think I'm going to go with the, did I say brown or red? I meant brown or orange. So I'm going to go with the orange, which is over here. I'm going to guess. And then of these here, 2 of them being correct colors, just in the wrong place. I already used the blue one. So I'm going to use the white one over here. I'm not using the black one. There's a reason why I didn't use the black one. I forgot. Anyway, check. Congratulations, you win. Now I wish it would show me actually 4 of these. It does show me 4 little of these red packs. So that's the game of Mastermind. Again, give it a try, and I do retract. You don't have to be totally successful on this one. Just try it and send a screenshot.